Alright, welcome to Static Electricity Guide Sheet number 1. We're going to start with the atom, so hopefully you can remember your basic chemistry. Electricity is a fundamental property of elements of the atom. The electron will have a negative charge, and the proton will have a positive electric charge. The neutron will be neutral. So if you're trying to draw an atom, you're definitely going to want a nucleus. That nucleus is the center of the atom. It should be pretty small compared to the size of the atom itself. Most of an atom is empty space. Within that nucleus, for our purposes, are the protons, which are positive, and that will vary by the size of the atom. And then the neutrons, which are electrically neutral. Now, I don't really need those for our purposes because they have no electrical charge. They have no impact on electric forces. They are important for mass, and therefore they are important for gravity. Around the nucleus are electrons. The electrons are tiny particles of negative charge. In a typical atom, there would be one electron for every proton, and that would be called an atom, and it would be electrically neutral. If you change the number of electrons, you will create what is technically known as an ion, which is a charged atom. Okay. Again, this is the nucleus here. And then around the nucleus is the electron cloud in which the electrons move. And they will be moving between various energy levels. And when they go between those energy levels, we'll typically get some kind of increase or decrease of energy from the atom. Alright, so the charged parts are the electron and the proton. The protons are positively charged. We typically use red colors if we're using colors for positive charge. On your car's battery, the positive terminal should be painted red or colored red. The electrons are negatively charged. The neutrons are not charged and thus for our purposes are unimportant. An electrically neutral atom is an atom in which it's not that it doesn't have protons or electrons, because then it couldn't possibly be an atom, but there must be a balance of the protons and the electrons. So for every piece of positive charge, you have a counterbalancing negative charge, so that the overall charge of the system, the atom, is 0. An electrically charged atom is referred to as an ion, and it can be distinguished in that it will have a different number of an imbalance of the protons and the electrons. And the way that is going to be brought about is that we're going to move the electrons. We might bring electrons in from someplace, or we might send them out to some other place. But it's not the protons that move because they are in the nucleus. We will need some kind of nuclear reaction to get them out. Okay, so protons and neutrons are located in the interior of an atom. That's the nucleus. They're tightly bound. It's the electrons that we're going to either eject or strip away from the atom or put onto the atom from someplace else. Therefore, if we want this oxygen atom over here to become negatively charged, I need an excess of electrons. Now, I can't get that excess by taking protons away. I can't reach into the nucleus and move protons. So the way I can do that is to bring in additional electrons from some source. Here I'd be a -3 ion compared to what I was before. If I want it to become positively charged, then I need to have a lack of electrons. I need to reduce the number of electrons that I have. So I'm going to get rid of some of those electrons, get rid of all the extra ones that I brought in, And I would also have to X out or get rid of, strip away or send away at least one more electron. Now this time I sent 2, so this would be plus 2 in terms of the ion. Again, it's not the protons that move, it's the electrons that move. We either add them to create negative charge imbalance or subtract them, take them away, to create a positive charge imbalance. Okay. An object that is negatively charged therefore must have more electrons than the number of protons. An object that's positively charged therefore must have less electrons compared to the protons. And for it to be neutral, they must have a balance. Typically that's what happens in nature, is we want to balance. What we're going to see are situations where we're going to get current electricity because the electrons are going to try to rebalance what they had before. Therefore, negatively charged, the electrons will be greater than the protons. Positively charged, they'll be less than. And electrically neutral, they will be equal to. Now, there is a fundamental property in that every electron has a charge of negative 1.6 times 10 to the minus 19th coulombs. Coulombs is how we measure charge. That's a capital C for the unit. If we want to know how much charge we happen to have due to a number of excess or deficiencies of electrons, then we're going to simply multiply by that value per electron. So example, in the first one, object A, I have 1 times 10 to the 3, that's 1,000 excess electrons. I'm going to multiply that by negative 1.6 times 10 to the minus 19th, and that'll give me the amount of charge that I have. Now since I have extra electrons, it's going to turn out to be a negative charge. And since I have 10 to the 3, when I multiply, I'm going to add the exponents, and so I'm going to have 1.6 times 10 to the minus 16th coulombs of charge extra on this particular object. Okay, so that's 1,000 extra electrons. So go ahead and calculate the other 3, and then I'll pause it for a bit here, and then come back and check your answers in a minute. Okay, so there are the answers. Notice if the electrons are excess, then we're going to get total negative charge. If the deficiency in electrons means we have more protons, so we'll have a positive charge. In this case, scientific notation, you just want to add the exponents together and then multiply the coefficients out front. I've rounded off everything to 2 significant figures. So electrons carry a very tiny amount of charge, but of course, a typical object, you will have billions and billions and billions of electrons. Now you might think that means everything is going to be incredibly electrified, but again, typically, for every positive charge in an area, there'll be a negative charge, and they will simply balance each other out, and you won't feel any electrical effects. Okay, during a physics lab, a plastic strip was rubbed with cotton and became positively charged. So we have the plastic strip as positive. The correct explanation for positive charge, again, is that it cannot acquire extra protons from anywhere. Okay, and protons can't be created. It's the electrons that move, and they would have been moved to the cotton, in this case, leaving behind the positive charge on the plastic strip. Miss Schiff and the 7th grade science greets her students in the unusual manner. She likes to scruff her feet, build up a charge. Since the electrons move from the carpet to her shoes, to her body, then her body is going to have an excess of negative charge, so she will be negative. Then when she touches her students on the nose as they enter, which probably isn't very nice, some electrons will leave her and move over to her students. Now, as some of them move, she will become less negatively charged, and the student will become more, and will become now pick up some of that negative that she had, and it will become negatively charged to a certain extent. So we call that charging when you touch something, charging by conduction, and you always get the same sign of charge. If you are negative and you charge by conduction, you'll get negative. If you're positive and you charge by conduction, the other object will also become positive. Okay, and finally, Aaron again suggests a sample of wool became positively charged by gaining protons. Boo, boo, boo. It's not the protons. Again, it would be positively charged by losing the negative charges, which are the only ones that can move. So it will lose electrons. And whenever you gain or lose, an object gains or loses an electron, the total charge of the system has to stay the same. So if the wool lost electrons, that means the balloon would gain it. So as we're doing the experiments and we're rubbing something rubber with wool, you're simply going to get a transfer of electrons. You didn't create charge. You can't create charge. You can only move it from one object to another to create an imbalance. Okay, that's the basics of what charge is. It's measured in coulombs. There's negative 1.6 times 10 to the minus 19th coulombs of charge on every electron, and by definition there's positive 1.6 times negative 19th coulombs of charge on every proton. That's it for this episode.